All right, so in this problem here, I'm looking at your notes, and I'm looking at the very first sample that we started in class today. I think for some of you guys, we did finish the problem. For some of you guys, we didn't. But I'm just going to go through it one more time with you so you guys are clear on how to solve out mole conversion problems like this. The very first thing that you want to look at here is where it says how many moles of calcium phosphate are in 43.67 grams of your actual compound. And if you were to take a look at calcium phosphate, the very first thing you have to do is you actually need to remember your polyatomic ions and our rules for writing out our chemical formula. And calcium we know has a positive 2 charge, phosphate has a negative 3 charge. And if you switch, drop, and reduce this, you would get Ca3, and you would wind up with 2 phosphates like this. And the formula for this matters because if you go back and look at your notes, we are going to be making use of 3 unit conversions that are pretty important in mole conversions, and I'm just going to write them up here. We know that if you have 1 mole of something, it's always equal to your molar mass, which you get in grams. And remember that your molar mass always comes out of numbers straight out of the periodic table. And we'll be doing one of those together. We also know that a mole is equal to Avogadro's number, which is 6.22 times 10 to the 23rd things. And in our case, we're looking at atoms, particles, or molecules. And you could also say that these 2 things are actually equal to each other. So we could also state that the molar mass in grams is equal to 6.022 times 10 to the 23rd atoms, particles, or molecules. Okay, so in our problem over here, you're looking at 43.67 grams, and I'm trying to convert it out over to moles. So I'm just going to go ahead and set this up over on the side. We have 43.67 grams of calcium phosphate, and I'm just setting up dimensional analysis. I want to put grams on the bottom so they cancel out, and I'm trying to change this out to moles, so I put mole on top. Now, looking at the 3 unit conversions that we looked at up here, okay, I'm going to make use of my first one, which says that 1 mole of anything is equal to your molar mass from the periodic table out in grams. So this is where it actually does matter that calcium phosphate is Ca3PO4 2. I need to figure out what the weight is of calcium phosphate in grams from looking at our periodic table, so I could stick it right into my dimensional analysis box right here. So if I were to break this down further, I could see that calcium phosphate is made up of 3 calciums. My 2 gets distributed in, so I know that this is 2 phosphoruses. And we have 4 times 2, so this is going to be 8 oxygens. Okay, so I'm going to come up with these numbers just by going over to our periodic table and getting the numbers from here. Like for the calcium, I see that it's 40.078. My phosphorus has a weight of 30.974, and the oxygen has a weight of 15.999. And anytime you guys actually see oxygen here, you could just use 16.00 for that. And we're just going to go through and multiply everything out, and then we're going to add it all up together on our calculator. So it's 3 times calcium, which is 40.078. My phosphorus is 2 times 30.974. Okay. The oxygens are 16, so it's 8 times 16. And all these numbers are going to get added together to come to my total molar mass. And I'm just going to punch that out on my calculator really quick. So we have 3 times 40.078 plus 2 times 30.974 plus 8 times 16. And when I punch this out, I get that many grams. So we're saying that if you had 310 grams of calcium phosphate, that would be how many grams are in 1 mole of it. So this goes straight into my setup here, okay? And my grams are going to cancel out, and I'm left with my unit of moles. So basically, to go from grams to moles, you just divide by your molar mass and you'll get to your answer. So I have 43.67 divided by 310.182. And when I divide that out, I would get 0.140788. But I need 1, 2, 3, 4 sig figs. So this would be 0.1408 moles of calcium phosphate as my answer. Now I'm going to go on and look at our second problem that we have here. And in problem 2, it says how many molecules of calcium phosphate are in 43.67 grams of the compound. So we're starting off with grams again. Thankfully, it's calcium phosphate, and let's just write in the molar mass that we found earlier. Earlier, we found that it was 310.182 grams, because we're going to reuse that. And this time, instead of going to moles, we actually want to go to molecules. So if you look up here, we're going to try to pick out which of the 3 we're going to use here. So I have grams and I'm going to molecules. So it looks like we're going to be using a third conversion over here. We have grams being equal to that many molecules. Okay, so we're going to make use of that conversion factor to get to our answer. So for setup, you have 43.67 grams. It's the same thing as before, so we're just using dimensional analysis. I want to get rid of grams, so it goes on the bottom. And I am trying to convert it to molecules this time, so I'm going to put molecules on top. And for the units, or for the numbers that actually come in here, the molecules goes with the 6.022 times 10 to the 23rd. Okay. Now for the grams would come from your molar mass, which we saw for earlier in problem number 1. So we're just going to plug in, it's 310.182. These cancel. And to get to molecules, you're basically going to multiply 43.67 times 6.022 times 10 to the 23rd. And then we're going to divide that number by 310.182. And we need 4 significant figures in my answer, so I got 8.478 times 10 to the 22 molecules. Okay. And let's see, we have number 3 to look at as well. So we have 33.64 grams of ethanol, and you're trying to count how many moles of carbon we have in the molecule. Now this part is pretty important. I'll go over that when we get there. But looking at the name, this is back from Unit 2 again, which you guys have to know how to write out the formulas. Eth, remember, is 2 carbons. Remember, meth is 1, eth is 2, prop is 3, but is 4. And this is ethane, so we know that it's going to be H is 2n plus 2. So 2 times 2 plus 2, which gives us 6. The all indicates that it's an alcohol, so we need to add an OH to the end. But in doing so, we take off one of the hydrogens, and it ends up looking like that, C2H5OH. And you're trying to solve from grams, and you're trying to go to moles of carbon. So let's go ahead and set it up over here. We have 33.64 grams of ethanol. I'm going to actually start writing out what the chemical compound is. And if you're looking at how we're converting, you want to get rid of the grams, so it goes on the bottom. And we're trying to get to moles here. Okay, But remember this, the grams that you have of the ethanol is equal to how many moles of ethanol you have. It's not moles of carbon yet. But let's go ahead and fill up this part here. In order to get the molar mass of my C2H5OH, we're going to take a look at our periodic table. And why don't I do it up here? So we have C2H5OH. So we could break this up into 2 carbons. We have 6 hydrogen, and we have 1 oxygen here. So we're going to add up all the weights, again, using values that we have from our periodic table. So my carbon, let's go ahead and find that. That's 12.011. My oxygen is 16. And my hydrogen over here is 1.008. So let's make use of that. It's 2 times 12.011, 6 times 1.008, and then 1 times 16. And we're going to just punch this out onto our calculator and add all those up. So 2 times 12.011 plus 6 times 1.008 plus 16. And we wind up with the molar mass of 46.07 grams here. Okay, so in 1 mole of ethanol, the weight of that ethanol would be 46.07 grams. So 1 mole of ethanol, so we're using this unit conversion right here. 1 mole is equal to the molar mass in grams. And we could say that 1 mole is equal to 46.07 grams of the ethanol. So check out your units. My grams of ethanol cancel. And we're left with moles of ethanol, but look at the problem here, because they don't want moles of ethanol. They actually specify that it would like moles of carbon in the molecule. So we're going to go 1 more box over, and I have moles of ethanol here, so that's what I want to cancel out. Okay. And in 1 mole of ethanol, you take a look at how many carbons we actually have there. So in the formula for ethanol, it's made up of 2 carbons. So you would just say that it's equal to 2 moles of carbon. So every mole of ethanol has 2 moles of carbon. That's like saying in 1 car, you would actually have 4 wheels. It's kind of the same thing. In 1 mole of this, you have 2 carbons inside of it. So these cancel out, and you end up with moles of carbon as your final unit, which is what we were going for. And you're going to go and solve 33.64 times 2. I got 67.28. Now I'm going to divide that by whatever I have on the bottom, 46.07. And I am looking for 4 significant figures here, so it rounds to 1.460 moles of carbon. And now we are finished.